we move on to the next. In fact, we are about to begin this pair, the one which I was saying, that is we recapitulated what we were doing in the last few classes. That is where we established the relation between pair of elements x and y. That is, we did x is related to y. Now we will do pair of elements related to another pair of elements, that is xy related to uv. And for that we have taken a question. The question says, prove that the relation R on the set n by n defined by AB related to CD implies A plus D is equal to B plus C. That means what? This pair AB is related to another pair CD of the set n by n by the relation that A plus D, that is first component of the first pair, added to the second component of the second pair, the value that I get is the same as the value that I get between the other two additions. That is, adding the second pair, the second component of the first pair to the first component of the second pair. Okay, this is the relation. You have to show that this relation, or whatever pairs I take, is an equivalence relation. So first thing is, I will show that it is a reflexive relation. That means I have to show that if I take a pair AB in the set n by n, then I have to show that AB is related to AB. Okay, for any pair AB that I take from n cross n. Okay, so therefore, let me check what is AB, RAB by definition that is given. What does it mean? AB related to AB implies, this is the first component, this is the last component. So A plus B, okay, is equal to, this is the first, this is the second, is equal to B plus A. This is what it gives us. Now this is always true. This is a property which is always true for addition. This is a property which is satisfied by, we call it commutative property, isn't it? So this is a property which is always true when I add elements. So therefore, AB pair belongs to this. So you will write, therefore, you will mention over here for, no need, okay. Therefore, R is reflexive. So therefore, AB, RAB holds. I think we'll write that first, as AB, RAB is true. You can add this, okay. As AB related to AB is true, that is why I can say that R is reflexive. Now I will show that R is symmetric. Okay. How will I show that R is symmetric? That means I have to show that if I take a pair AB related to CD, then it implies that CD is also related to AB by the same relation that is defined in the question. This is what I have to show. So let me check what is LHS, that is the left hand side. If I consider AB, which is related to AB, what does it mean? It means that A plus D, the same thing, A plus D is equal to B plus C by definition in the question. Okay, by definition in the question, AB is related to CD means A plus D is equal to B plus C. We gave it an equation number. Now let us check the right hand side. The right hand side is what? CD, if it is related to AB, then what should it satisfy? It should satisfy the property that first component with the this plus this, that is this plus this, C plus B should be equal to the remaining D plus A. Okay. So this means, this is again by given definition. This in turn means this is your B plus C, this is your A plus D. Why? Because we know commutative property holds. By commutativity, you cannot see, by commutativity of addition. the operation addition is commutative. That is why this holds. This in turn means what? Which is same as equation 1, isn't it? Which is the same as equation 1. So therefore I can say that if this is happening, then this is also happening. Okay, so you will write that thus if AB is, this is the definition that is given. Okay, thus if AB is related to CD, it implies CD is also related to AB. Therefore, R is symmetric. Now, subpart 3, I will show whether it is transitive or not. That is to show that if AB is related to CD, okay, and CD is related to something else, CD is related to suppose EF, then you have to show that it implies that AB is related to EF. This is what I have to show. Okay. So I am assuming that AB is related to CD where, please mention where AB, I hope you can see, you cannot see, where AB, comma CD and the pair EF, they all belong to the Cartesian product of natural numbers. Okay, so this is what we have to show, that if I assume that AB is related to CD and I assume that CD is itself also related to another pair EF, then I have to show that the first pair AB is related to the last pair EF by the relation that is given. This is the relation that is given. I have written it separately and kept it in front of me so that I don't have to, so that I can refer to it very easily. Now, therefore, what do I have? So, this. Now, since I have assumed that AB is related to CD, so you will write, since AB related to CD implies, what does it imply according to this? A plus D is equal to B plus C by definition that is given. Okay, this is the definition that is given. Similarly, I'll give it an equation number, suppose 1, and if I assume that CD is related to EF, then I can say that the first and the last component, that is C plus F, is equal to D plus E. Again, this comes from the definition that is given. Now let me check what happens to the pair, this one, what do you call it, AB and EF. That means I need this, and I need this and this. I don't need C and I don't need D. Okay, in order to establish the relation between them. So what can I do? One thing you can do is you can subtract, because then D and D will cancel. Yes, or you can add. Even adding will cancel from either side. Okay, just for the sake of simplification, I am adding. Adding gives me what? This side it is A plus D plus C plus F. That side it is B plus C plus D plus E. Whichever way helps in manipulation, you can apply. So C and C cancels from both sides, D and D cancels from both sides. Okay, and as a result, what do I get? This means A plus F is equal to B plus E. And what does it mean? AF is related to BE. It means that AB is related to EF. Check and see by converse definition, or simply by definition. Okay, by definition. Check and see if AB is related to EF, then what should I get? I should get that A plus F, which I have got already, is equal to B plus C, which I have got over here. So I can conclude that AB is related to EF. You can do it some other way also. For example, you could have, after writing this, now you could have checked AB related to EF. What does it give you? A plus F is equal to B plus C. And then what will you do? In place of A plus F, or maybe in place of A, you could replace one of these equations, that is B plus C minus D, replace it. And in place of what is not needed, therefore, and in place of this, you can replace one of these, that is suppose this one, terms will cancel, it will lead to this and this. That way also, like back calculation way also you can do. Okay, so conclusion will be, thus AB related to CD and CD related to EF implies that AB is related to EF. This is what I have, and hence what is the final conclusion? Therefore, R is transitive. First you will write that. So, R is transitive. Combining, final conclusion will be combining 1, 2 and 3. Hence, therefore, R is an equivalence relation. Okay, combining 1, 2 and 3, R is an equivalence relation. That will be your final conclusion. Okay, so this is for ordered pairs that we take, and the relation between ordered pairs. Previously it was one ordered pair taken and the relation between the components of that ordered pair. Now it is two ordered pairs taken and the relation between the ordered pairs. That is what we have applied over here. Let us do one more of this type.